Hey, this is a video for 4.2b, Soil Formation and Erosion Horizons. So go ahead and check out the overview and set up your guided notes. So, soil forms from parent material. Parent material is most often the most closely related thing to the bedrock. And bedrock is just the layer of the Earth's crust that is the origin of the soil. So this is the bare rock that the soil formed from. And oftentimes you're going to have pioneer species like lichen or mosses. So remember, the lichens can contribute to chemical weathering by releasing acids that will break down this rock. So eventually you'll break it up into smaller and smaller pieces. You're going to get partially weathered rock. And this is where you may have mosses that will be able to form there, because mosses are plants. They're more primitive than the plants that you know, but they're a little bit more advanced than lichen. Now, over time, eventually you're going to have areas where you can support organic material, like plants in the soil. You're going to have distinct layers. So at the very top, you're going to have the topsoil, you're going to have organic material, and then you have areas that are known as subsoil. And the subsoil is very closely related to this parent material. Parent material, again, is like bedrock. Now, this is important because soil forms from above, the organic material. Through decomposition, it generates organic material, or it's generating rich organic humus. Erosion can also contribute to deposition of minerals and other nutrients, so that the soil may be moving from one place to another. You also have soil forming from below, the weathering and the minerals. So you can have other things coming from on top and things coming from below to form all soils. So soils like limestone are going to have a higher pH. They're going to be better equipped for agricultural purposes. That is important when we come and talk about farming. But this is going to make the pH higher. Remember, calcium carbonate is a base. So we have distinct soil horizons, and they are: the O horizon is the organic material. And you really can't see a lot of the O horizon here, but O horizon is going to be partially decomposed organic material, this humus. Then you're going to have this A horizon, and the A horizon is this dark layer, and the dark layer is because of all of the organic material that's in there, but it is also known as topsoil. So it is topsoil with organic and mineral materials. This is where you're going to see a lot of biological activity. Then you move down to the E horizon. And the E horizon is not always present in every soil, but you're going to have this zone of leaching. It's named the E horizon because it's the zone of eluviation. You never have to know this word, but that's where the word E came from. Leaching is when all of the minerals are coming down from above and then they're accumulating in an area. So the minerals will wash through the organic layer, the O horizon. It will wash through the topsoil. It will start collecting in this E horizon. That's why you notice it has a different color. And then you will have the B horizon, and that is known as the subsoil. Okay, the B horizon is closer down to the parent material. And if you see a diagram and there is a C horizon, it's going to be the one that most resembles the parent material. Now, if you're ever asked, as you go farther down in the soil horizon, the one at the bottom is going to always most resemble the parent material. The one that's going to least resemble the parent material is very likely going to be one of the layers at the top. So sometimes you'll see 5 layers, sometimes you'll see 4. It depends on. But if you do have an accumulation of minerals, the E horizon is not always present. But when it is present, it has to be underneath the A horizon. Okay, and the very last layer, and you don't see it here, is the bedrock. And sometimes that will be called the R horizon. Oftentimes, C and R, they may be interchanged. I'm not a soil scientist. There's a lot of discrepancies in the way that the vocabulary is used in the College Board. Now, plants do 2 great things. They prevent erosion, they purify water. I always tell students, plants are staplers and sponges. They're absorbing water, but as they absorb the water, they're purifying it because they're taking out those pollutants. They're also preventing erosion by holding the soil in place. Whenever we remove the plants, we're essentially, even though we're not technically doing it, we're allowing the soil to be removed as well because you're taking away the protection. So there's a feedback loop. So what happens is you may have increased erosion. That increased erosion will result in reduced plant growth. With reduced plant growth, you're going to have less root structure. That less root structure is not going to hold the soil in place, so the soil will erode again. So a positive feedback loop is one that is like self-perpetuating. It will just keep going because one thing will lead to the next, which will lead to the next, which will lead back to the first. So what I would like you to do is practice what you've learned by completing practice problem set 4.2b. I hope that this video was informative. I thank you for your attention, and I'll see you soon.